What exactly is a quantum state? You've probably heard this word everywhere in physics, but what even is it? First, let's understand what a state actually means. A state is simply the complete information needed to describe a system. For simplicity, let's start with a classical system. Take a ball. If you know where it is and how fast it's moving, physics can predict what happens next. That information, the combination of position and momentum, forms the classical state. But in quantum mechanics, things become stranger. We can no longer describe reality using exact position and momentum in the classical sense. Instead, quantum systems are described using something called psi, the quantum state. Everything we can predict about the system, position, momentum, energy, and more comes from this state. But here's the strange part. We still don't fully know what this state physically is. So we mathematically represent it using something called a wave function, which is essentially the projection of the quantum state onto our position coordinate system. And all we truly know is how this state evolves with time, an evolution governed by the famous Schrödinger equation. So coming back to the question, a quantum state is something with a far deeper structure, while the wave function is only the surface level representation of the state that we can mathematically access, at least for now.